start with depositing money, okay? Helen is opening her first savings account, and she's depositing $500 into this account, and her bank offers 6% annual interest. This is the formula for compound interest, okay? Now, they're telling you to recall this, like you remember this, like you've seen it before. So let's go over what this means, okay? Amount, A is the amount. It's either the amount that you owe or the amount of money that you have, okay? That's A. P is the principal. You know what the principal is? Principal is your original amount, okay? What's Helen's principal? 500. That's the principal. That's P. Okay. Then there's 1 plus R, which stands for your rate. What's Helen's rate? 6%. Okay. One thing to remember: percents are for show. What do we work with? Decimals. We work with decimals. Okay. And then T is the amount of time in years that we have this in decimals. And that's what all those letters mean. We're going to add another letter to it in just a minute. All right, so Helen's savings account after T years. All right, so A of T. How much money was her principal? 500. What was her rate?
106.
And time is T years. All right, so that's the answer for question 1 right there. That's the answer for question 1. She did 500. 1 plus 0.06. Does anybody know why it's 1 plus 0.06? Nope. It's always 1 plus your interest rate. Because what? Alright, if I deposit $500, and at the end of the year, how much money will I have? More, right? I'll have the entire 500 plus 6%, right? What percent of 500 is 500? 100%. What's 100% as a decimal? 1. You get the whole thing, 1, plus 6% more. That's why we do 1 plus the interest rate. You just get your 6%. Exactly. You get the whole thing plus the 6%.
I got a question.
Yes.
Can you take something out of a savings account?
Can you what?
Can you take money out of a savings account?
Most of the time, yeah. Some, like very few savings accounts, can you not touch. Like CDs, you can't have those. Once they're in, if you take them out, you have to pay a huge penalty. But if it's just like go to the bank and open a savings account, yes.
So say I put 500 in, I wait a year, 6%, like 530, and I take about 100 out, so it's 430. Would it be 6% off
Of the 430.
430? Okay.
Yes.
And if you add some more money into that, it'll just go on top of it.
Yes. And they figure out how much of the year, like let's say you had 530 in, and then like 6 months in, you put in another $100. They're going to give you that 6% of the 530 up to that point, and then they'll give you the 6% of the rest of it after that. So they figure out exactly how long you've had all of that in there. Yeah. So anyway, all right. So we know at the end of 1 year, you've got 500 times 1.06 to the first power, and what does that equal again? 530. So at the end of the year, Helen has $530. All right, how much money will she have at the end of 5 years? If she doesn't touch it, doesn't take anything out. Figure that out. How much will she have at the end of 5 years? Alright, so how much does she have at the end of 5 years if she doesn't touch it? Okay, why do I know that I have to round to the hundredths $6,000, so I have to round to the hundreds close. Okay. Did everybody get that answer?
Yes.
$669.11. Okay. So let's look at the next question. Suppose the bank decides to start compounding interest at the end of every 6 months. Okay? It's still going to be 6% for the year. How much interest would they offer per 6 month period? 3%, right? Because it's being split. Alright? Good. Okay. So if we compound it,
Do you get the same amount of money?
no.
You,
No.
you keep it.
Well, let's see. If we compound it, um, it's still 6%, but it's happening 2 times in a year, right? 3% each time. And it's 1 year still. But how many times did it happen in that 1 year? Okay? That's our new number, by the way. The number of times it's compounded. Alright, so remember it was $530 when we just did it once a year. What's it going to be when it's twice a year? What's that answer going to be? A few years. $530.45.
So that's where you have it at the end of the year.
That's what you would have at the end of the year if they compounded it twice. Because what they're doing is they're stopping about halfway through and they're saying, all right, how much interest have you collected right here? They add that in, and then they go another 6 months and they take interest on the interest that you've already collected. So that's called compound interest. It compounds on top of
I
itself.
got a question.
Yes.
If you put one like 500 times 1 plus 0.03,
Uh-huh.
do you put it to the half power or still?
That's 1 times 2.
So how can you put 1 times 2?
Because it happens twice a year. So the new formula, if it's compounded more than once a year, it's still your principal times 1 plus your rate over the number of times that it's compounded to the amount of time that you have it deposited times the number of times it's compounded. That's your new formula right there. Look on page 758. Look on page 758. Alright, on page 758, number 7, you got 3 problems there. Helen is still deposited $500. She's going to keep it in the account for 3 years. But we're going to compound it 3 different ways. Once we're going to compound it twice a year. So what would N be? 2. Well, guess what? We've got that one. Okay. Then we're going to compound it monthly. What's N going to be? 12. Okay. And then 365. Alright, so do those 3 and then answer number 8.
So
Twice a year for 3 years. We start out with our 500. Twice a year for 3 years. And how much do we end up with? 597 and some change, right? 0.03. Alright. Monthly.
For 3 years, or is it for life?
For 3 years. Monthly. That right there. And how much money is that? This one 598 something?
98.34.
Alright, and then the other one was 365 days a year?
That has a checking daily and
And what was this one? 5 what?
98.60.
Exactly. All right. So number 8. What happens? What effect does the frequency have? The, yeah, the more you compound it, the more it increases, right? So, and that's true. The more often you compound the interest, the more money that you will get. You could do this that's daily. If you could do it every hour, it'd be a little bit more. If you could do it every minute, it'd be a little bit more. If you could do it every second, it'd be a little bit more. Until you reach this thing called continuously compounded. Okay? And continuously compounded means just what it says. It's continuously, instantaneously,
Where's that in?
always being compounded. Right? And that uses a special number.
E.
E. Right. Okay, now, the number. The number E. Okay, the number E is this number right here. 2.718 and so on. Okay? It's often referred to as a natural base. There is a guy with this name right here. Leonard, we say Euler, like Bueller. His name is actually Euler. Yeah, he's Swiss. What? Okay, he's Swiss. His name is Leonard Euler. When he was 21, he first named this number in a book that he was writing. And I have to read the name of the book if you can't remember it. It's called Meditation on Experiments Made Recently on the Firing of a Cannon. That was the name of the book.
What?
Yeah. And he was 21, and he used this symbol, E, to represent this number. Okay? Yeah. Some people think he chose E to stand for exponential. Some people think he chose E because of his name.
I think his name.
If I invented a number, it'd be Harper. Okay? I'm just saying. That would be the number. But anyway, he's not the first to come up with this number. John Napier, and we'll talk more about John Napier when we start logarithms. John Napier first worked with this number, but Euler's the one who named it, okay? And he was studying continuously compounding interest of money when he came up with this number.
Where does the cannon come
I have no idea. But this is how he figured out finding it. E equals 1 plus 1 over 2 plus 1 over 2 times 3 plus 1 over 2 times 3 times 4 plus 1 over 2 times 3 times 5, 2 times 3 times 4 times 5, and so on, and so on, and so on.
How far is that going?
Forever. That's what E.
So he's supposed to
It's like pi. It never ends. It never repeats. It's an irrational number. So we just call it E for short. Okay? Now, what does it have to do with interest? Well, yeah. If you compound interest continually, you have a different formula that I just call PERT. PERT, because that's what it is. It's the principal. And what's the principal? Original amount, okay. Times e to the RT. Principal times e to the rate times the time. That's PERT. That's for continuously compounded interest or anything that grows continuously. Let's talk about Fredericksburg. All right, the population of Fredericksburg was 19,360 in 2000 and has been continuously growing. All right, that continuously right there tells you that this is a PERT problem. Okay? It's continuous. So that's what it is. All right? Growing at a rate of 2.9% each year. Use the formula for population growth. That's this. To write a function to model this growth. All right, so what's our original amount here? What's our principal?
2,360.
And our rate? What am I going to write for the rate? No, I'm going to put 029, and I don't know how many years, so I'm going to put T. So that's my population for whatever.
Let's put a line on one times.
Because on the next question it tells me when. It says, okay, well then use this to predict population in 2013. So if it's 2013, what's going to go in for T?
13.
Why 13?
13 years after.
Alright, the first one, the initial was 2000, the next one was 2013, a difference of 13 years, okay? So it's going to be 19,360 times E. There's a button, there's an E button just above LN. So you have to hit second, LN. See LN, it's over there, kind of close to the 7. It's in the area under the 7. If you're using your phone, you can turn your phone sideways. It also has an E on it.
When you're just working percentages,
I got it.
Is it the double E?
That's what.
That's it.
Is it the second one?
Alright, does everybody see that? So what's the population in 2013?
28,225.
And why are we not doing decimals on this one?
People take out the points on
People,
people.
a person's a person, no matter how small. So we're not giving you points. Alright?
I swear, I think person to person, no matter how small, I swear to God, I think that's a tagline for a movie.
It's Dr. Seuss.
Aha. I was mistaken.
Alright. What about 1980?
1980.
That's backwards.
Yeah?
Five,
I'm not going to divide.
right?
How much time passed from 2000 to 1980? Negative 20. Right. I'm going to put negative 20 in right there. Because it's going back in time. T is negative 20. So how many people were in Fredericksburg in 1980?
2,939. Oh, it was sick.
Exactly. Very good. Everyone, get that on your calculator. You know how to push the buttons on your calculator. Get that answer. Okay. 5 and 7. 19,000. And see, it automatically is ready for an exponent. Because we're really not gonna be dealing with E unless we're dealing with exponent. Alright, get out. Skills practice 10-2.